Welcome to Day 1 of Algebra 2 Lesson 7.6, Solve Exponential and Logarithmic Equations. First main concept for the day basically says if you have a power that's equal to another power and the bases are the same, then you can conclude that the exponents are also the same. So this statement reads, if b is a positive number other than 1, then b to the x equals b to the y if and only if x is equal to y. The IFF is the abbreviation for if and only if, which is stating that this statement here is a biconditional, meaning it works from left to right or right to left. So the example below shows an example when we use the statement from left to right. We have two powers that are equal to each other. We have 7 to the 2x is equal to 7 to the x plus 4. Because the base is the same, they're both 7s, we then can conclude that their exponents are equal. And now we have a simple Algebra 1 problem to solve. We'll subtract x from both sides, and we are done. We now know that x is 4. Let's try one that's a little bit more involved, with a new statement saying, if b is a positive number other than 1, once again, if b to the x and is equal to b to the y, then we know that x is equal to y. The statement would also read if x is equal to y, you can make those the exponents of any statement you want. So let's try one more example like the one on the previous page. So we look at this, we don't have bases that are the same. On the left side, our base is 9, and on the right side, the base is 27. We need to rewrite each of these statements. They both have the same base. How could we rewrite 9 as a base and an exponent? Just looking at the 9. 9 is the same thing as 3 squared. Let's look at the 27. Could we rewrite 27 as 3 to an exponent? Yes, 3 cubed is 27. So I'm going to rewrite the above statement. Instead of a 9, I'm going to put a 3 squared, and that's raised to the 2x power. Instead of 27, I'll write 3 cubed, and that's raised to the x minus 1 power. Using my power to a power property, I will clean up my exponents and see what I really have on the left side is 3 to the 4x, because that's what 2 times 2x is, and the right side becomes 3 to the 3x minus 3, because that's what you get when you distribute 3 to the x and 3 to the 1, 3x minus 3. Now we have established the statement up above that we have bases that are the same, therefore I can conclude that my exponents are also equal. Once again, it's a simple Algebra 1 problem. Subtract 3x from both sides, and you now have that x is negative 3. In this statement, we want to solve this by equating exponents. We want to be able to set our exponents equal to each other, and that's really what we were doing in the previous two examples. When the two bases are the same, you can set the two exponents equal to each other. But right now, I have a 4 for a base and a 1/2. Let's focus on the integer. Could 4 be rewritten as a power? Yeah, 4 is 2 squared. Could I rewrite 1/2 as 2 to an exponent? Big hint is that whenever you're dealing with a fraction, you're most likely going to have a negative exponent. So you need to recall your negative exponent property. So if I rewrite 4 as 2 squared, I could rewrite 1/2 as 2 to the negative 1, recalling that your negative exponent property changes the 2 by putting it in the denominator and making the exponent positive. So if we go from this statement to the one up above, 2 to the negative 1 is the same thing as 1 over 2 to the positive 1. So now that both statements are written with base 2, I'm going to clean up my exponents using my power to a power property. 2 times x gives me 2x. Negative 1 times x is my negative 1x. Negative 1 times what in essence is a negative 3 is a plus 3. Now that my bases are the same, we can officially equate our exponents here. I'm going to add 1x to both sides, divide by 3, x is 1. The last kind of problem we're going to take a look at is one in a section where you will be instructed to take the logarithm of each side. What that means is I'm going to take the log of the left side and the log of the right side. Just like in any basic Algebra 1 problem, if you do something to the left side of the equation, you have to do it to the right side. But what log base do I want to use? Look at what the base is here. This is a base 4 to the x power. I'm going to take log base 4 of the left side and log base 4 of the right side. Recalling from a previous lesson, when you have a log base 4 of 4 to a power, in essence, the log base 4 and the 4 cancel, and my left side will simplify to simply x. The right side is log base 4 of 11, which you'll pick up your calculator to evaluate. Or at times, it's perfectly okay to leave it log base 4 of 11. With your calculator, though, you should be able to establish that log base 4 of 11, when you are rounding to the hundredth, is 1.73. This ends the first half of Lesson 7-6, and there's your assignment for today.